The communication system is used for any air-to-air and air-to-ground communications, any internal aircraft communications, passenger address. All communications are recorded on the cockpit voice recorder, CVR. The communication system also provides an emergency locator transmitter, ELT, oral alerts generated by the flight warning system and T2 CAS through the cockpit loudspeakers, and the navigation source identifiers reception. The communication system comprises an audio integrating system which manages all audio signals, a passenger address system, PA, to broadcast announcements and audio signals between the cabin and the galley, a cockpit voice recorder system, CVR, which enables recording of conversations and oral alerts and signals, a VHF system used for short-range communications, a radio management function, RMF, which ensures the correct management and the information exchange between the interfaces and the equipment. The communication system offers as optional features an HF system for long-range communications, a selective calling system, CELCAL, which enables communications from the ground to a specific aircraft, an aircraft communication addressing and reporting system, ACARS, which provides the transmission of digital data to and from the aircraft. The audio integrating system is composed of a remote control audio unit, RCAU, which is the heart of the system located in the avionics bay. The remote control audio unit interfaced with the audio control panel, a headset and microphone set, a flight warning system, a TAWS, and a TCAS. Two audio control panels, ACP, are located on the pedestal. They enable selection of transmit modes, audio level adjustment, selection of a band suppressor filter, and interphone radio push-to-talk control. The ACP is composed of volume control knob to control reception volume for associated communication or navigation facility, transmission keys to select the individual communication facility for transmission. 6 interlocked keys are provided. Only one key can be engaged at a time. It illuminates white when selected. Note: HF1 and HF2 transmission selection keys and HF1, HF2, MLS, ADF2 and DME2 audio level adjustment knobs are already installed on the audio control panel, but will of course be inoperative if the systems have not been installed. Voice-only key. When depressed, it inhibits nav receiver's station identification by activating a band cutoff filter above 1020 Hz. Voice-only light illuminates amber on audio control panel. The audio control panel is also composed of an interphone radio selector, which provides selection of transmission mode when using the oxygen mask or boom set mic. INT, interphone hot mic position. Interphone is always operative between crew stations. Other transmissions require selection of a transmission key and using a push-to-talk push button. Neutral, interphone is inoperative. Other transmissions require selection of a transmission key and using a push-to-talk push button. Radio. This position is required to automatically connect boom set and oxygen mask mics for transmissions without using a push-to-talk push button. When released, the selector is spring-loaded to neutral. Two cockpit loudspeakers are installed in the cockpit ceiling, one above each pilot. Their respective volume control knob is located on each side of the instrument panel. A clockwise rotation increases the volume. A muting circuit attenuates the loudspeaker audio level during transmission in order to avoid acoustic feedback. Two hand microphones are provided on each side of the cockpit, one for each pilot. The hand microphone jack panels are a small unit provided on each side of the cockpit, one for each hand microphone. The microphone consists of a nylon cylindrical body with a rubber ring which protects against impacts. The unit encloses a microphone cell and the push-to-talk function is activated by means of a switch. The boom sets and headsets are located on each side of the cockpit. A third boom set is also provided for the observer. Jack panels, for connection of a headset and a boom set, are installed on each side in the electric and electronic racks. The boom set consists of a headset and a high-impedance microphone attached to a swivel rod. The boom set is used for any transmission reception, whereas the headset is only used for reception. Three quick-fitting oxygen masks are installed in the cockpit, on the left and right pilot's consoles, and one for the observer. The quick-fitting mask is an oral nasal mask comprising a plastic facepiece with a comfortable silicone compound sealing pad covered with a high-quality elastomer. The microphone is attached to the oxygen regulator inside the mask and is activated as soon as the mask is being used. A reset push button is used to revert to normal communication means when the oxygen masks are no longer in use. A push-to-talk selector is mounted on each control wheel outboard horn. The push-to-talk is effective only when boom set or oxygen mask mic is used for transmission. This is a three-position push-to-talk selector, controlling the transmission mode. The neutral center position, which prohibits transmission. The interphone forward position, spring-loaded to neutral, which allows interphone communication when the interphone radio selector of the audio control panel is in neutral position and the interphone transmission key is not selected, i.e., oxygen mask use. The radio backward position, spring-loaded to neutral, which enables transmission according to the selected communication facility. A radio push-to-talk switch is provided on the steering control wheel on the captain console. It enables, when depressed, connection to a boom set or oxygen mask mic for transmission on the selected communication facility. The observer interphone radio push-to-talk selector is located on the left side of the cockpit access corridor. The push-to-talk is effective only when boom set or oxygen mask mic is used for transmission. This is a 3-position push-to-talk selector, controlling the transmission mode. The neutral center position, which prohibits transmission. The interphone up position, spring-loaded to neutral, which allows interphone communication when the interphone radio selector of the audio control panel is in neutral position and the interphone transmission key is not selected, i.e. oxygen mask use. The radio down position, spring-loaded to neutral, which enables transmission according to the selected communication facility. For ground staff communication, a control panel is located in the DC GPU receptacle. It is composed of a jack to connect a boom set and a call push button to generate a signal in the cockpit. Two audio cell push buttons are provided in the cockpit, one on the left side of the instrument panel for the captain and one on the right side for the first officer. When the push button is depressed, normal state, all communications transit via the remote control audio unit. The fault amber caution illuminates and the flight warning system is activated when an associated remote control audio unit processing board failure or power loss is detected. When the push button is released, alternate white legend illuminates. Remote control audio unit is bypassed. An affected crew station is directly connected to respectively VHF 1 for captain station and VHF 2 for first officer station. Pilot's intercommunication is lost. Volume is adjusted by affected loudspeaker volume control knob. Note: on the affected side, passenger address, interphone and other VHF and HF if installed can no longer be used. A call control panel is located on the overhead panel of the cockpit. On the attendant push button, when the call blue light illuminates, it indicates a call from the cabin. When the emer red light illuminates in addition, this means there is an emergency call from the cabin. When the push button is pressed, momentary action, a call signal is generated to the flight attendant in the cabin. On the mechanic push button, when the call blue light illuminates, it indicates a call from the ground crew. When the push button is pressed, momentary action, a horn generates a sound in the nose landing gear bay to alert the ground crew. The reset push button is used to cancel the visual and oral alerts after any flight attendant or ground staff call. The CellCal encoder is installed on the overhead panel with a protective glass to prevent any code change. When the call white light illuminates, associated with the two-tone audio signal, it indicates a call from HF ground station. When the communication is completed, a reset must be performed to allow another HF call to be detected. The pilots need to call the cabin attendant. On the audio control panel, the audio level is adjusted with the interphone knob, and the interphone radio selector is normally set to the interphone position. Transmission key can be on any selection. The pilots depress the Calls Attendant push button on the Calls panel. A chime sound is broadcast via the cabin loudspeakers, and the cockpit green light on the Cabin Attendant panel illuminates. The cabin attendant lifts the telephone handset and depresses the Call push button on the handset control panel. The indicator light associated with the Call push button illuminates green, while the cockpit green light on the cabin attendant panel extinguishes. In the flight compartment, Call light illuminates on the Calls Attendant push button, with a doorbell sound through the cockpit loudspeakers. The flight attendant handset audio channel and flight compartment are now linked via the remote control audio unit to communicate. Because of the repetitive doorbell sound, the pilot must perform a reset on the Calls panel by pressing the reset push button. The call light extinguishes and the sound is cancelled. Two solutions are used to communicate with the cabin attendant. With audio control panel selector switch on interphone position, the boom set allows permanent reception and transmission. With audio control panel selector switch on neutral position, it is necessary to depress the interphone transmission key and use microphones or push-to-talk switches to transmit. Headset or loudspeakers allow reception. At the end of the communication, handset is replaced on its holder. The indicator light extinguishes and the system returns to initial configuration. In case of emergency, the operation is similar to normal operation, except that the pilot has to press Calls Attendant push button successively 3 times. This activates 3 single chime sounds in the cabin loudspeakers. The cabin attendant lifts the handset and presses the emergency push button on the handset control panel, which illuminates red on the associated indicator light. In the flight compartment, on the Calls Attendant push button, call and emergency lights illuminate in association with a repetitive doorbell sound. The pilot then has to depress the reset push button and the situation returns to normal communication. Now the cabin attendant needs to call the pilots. The cabin attendant lifts the telephone handset, which is then energized, and presses the call push button on the handset control panel. The indicator light associated with the call push button illuminates green. In the flight compartment, call light on the Calls Attendant push button illuminates in association with a doorbell sound broadcast via the cockpit loudspeakers. Once reset push button is pressed, the call light extinguishes and the doorbell sound is cancelled. Both stations can communicate. After communication, the handset is put back on its holder. The indicator light on the handset control panel extinguishes and the system returns to initial configuration. In case of emergency, the operation is similar to normal operation, except that the cabin attendant has to depress the emergency push button on the handset control panel. On the handset control panel, the indicator light associated with the emergency push button illuminates red. In the flight compartment, on the call's attendant push button, call and emergency lights illuminate in association with a repetitive doorbell sound. The pilot then has to depress the reset push button to cancel the repetitive doorbell sound, and the situation returns to normal communication. The pilots need to call the ground crew. On the audio control panel, the audio level is adjusted with the interphone knob, and the interphone radio selector is normally set to the interphone position. Transmission key can be on any selection. The pilot depresses the call's mechanic. The mechanical horn rings in the nosewheel bay as long as the call's mechanic push button is depressed in the flight compartment. The ground crew can then connect his headset to one of the 3 interphone jacks in the ground power receptacle, in the hydraulic bay, or in the aft avionics compartment. As soon as he is connected, communication is established. 2 solutions are used to communicate with ground staff. With audio control panel selector switch on interphone position, the boom set allows permanent reception and transmission. With audio control panel selector switch on neutral position, it is necessary to depress the interphone transmission key and use microphones or push-to-talk switches to transmit. Headset or loudspeakers allow reception. Now the ground crew wants to call the pilots. The DC ground power receptacle provides a crew call push button. In the flight compartment, on the call's mechanic push button, call light illuminates in association with a repetitive doorbell sound. The pilot presses the reset push button to cancel the repetitive doorbell sound. Both stations can communicate. After using the oxygen mask, when the situation returns to normal, the crew must restore normal communication. First, the crew must close the oxygen mask compartment doors. Then, they must press the reset push button on the left side of the compartment to recover use of the boom set, headset and microphones. The VHF system is used for all short-range radio communication between aircraft in flight or on ground and ground stations. The aircraft is equipped with 2 independent VHF systems. Each system includes a transceiver located in the avionic bay, which provides communication channels from 118.000 to 136.992 MHz with 9.33 kHz spacing. A radio management application, RMA, hosted in DU2 and 4 to manage VHF parameters, and an antenna. Both VHF antennas are installed on the upper front and lower aft fuselage. VHF-1 system is powered by DC emergency bus and VHF-2 system by DC bus 2. VHF-1 is equipped with a backup tuning resource through the Integrated Electronic Standby Instrument IESI. The VHF system is also connected to the CVR and the Remote Control Audio Unit. Both VHF are connected to both radio management application, which are monitored by both flight warning applications, FWA, located in the core avionics cabinets. FWA acquires the VHF status from the RMA and generates alert messages according to the situation. Both MCDU and MCP are interfaced with the communication system through the RMA to allow frequency selection. The RMA information is displayed on the virtual control panels. ACARS, Aircraft Communication Addressing and Reporting System, also called Data Link, is a system which enables the transmission of digital data to and from the aircraft. The main purpose of ACARS is to eliminate the need to transmit routine information by voice communications. Additional advantages of ACARS are reduction of congestion on voice frequencies and transmission of large amounts of information in a very short time. In the cockpit, advantages are an organized display of information and text messages received which can be stored and displayed later. Two types of data can be sent to the aircraft. The Airline Operator Communication, AOC, sends pre-formatted text, free text messages, or interacts with the onboard AOC functionality. Air Traffic Control, ATC, sends message as digital ATIS, clearances, etc., or interacts with the onboard Air Traffic Services, ATS, functionality. On ground, various networks are available to transmit messages through different means of communication: satellites, antennas, computers, etc. These networks are managed by private companies such as AirInc, SITA, and other service providers. As the airlines use one or several providers, the different networks are interconnected and enable transmission, routing function, of messages from customers to various ground aeronautical stations. The aircraft, through a communication system, receives data. Three means of reception are available: VHF, HF, SATCOM. Note: VHF is the only means used on the ATR. The communication system transfers data receipt to the CMU, the heart of the ACARS system, which computes information. On the MCDU, data can be read by crew members. They can also answer the information provider or interact with onboard AOC functionality. A printer installed in the cockpit can be used to print any text messages or data for future reference. The Flight Management System, FMS, and the Multipurpose Computer, MPC, provide parameters and maintenance reports, which will be sent to the ground. The functional architecture of the data link communication is centered around the CMU, located on shelf 83 VU, receives the uplink and downlink digital messages from the VHF transceiver. It also controls the transmission of these messages through the VHF transceiver. Currently, one frequency is assigned to ACARS operation. The Aircraft Data Radio System. The VHF-3 antenna provides a means to transmit or receive radio frequency RF signals to and from the ground. Two MCDUs, multipurpose control and display units, provide an interface with ACARS to send and read data link messages or parameters. They are used to configure and operate the CMU. Printer allows printing of data link messages visualized on the MCDU. ECU, External Compensation Unit, located on shelf 83 VU, is used to store aircraft-specific configuration data. It remains with the aircraft during replacement of the CMU. The Data Loader plug, located on shelf 83 VU, is used to update databases and to define AOC applications in accordance with specific customer requirements. FWA, Flight Warning Application, is a software application hosted inside CAC1 and CAC2, located in 81 VU and 82 VU. The FWA acquires the system status and generates any failure message on EWD related to loss of data link. MPC, located in 81 VU, provides maintenance reports, which will be sent to the ground. CMA, Centralized Maintenance Application, is a software application hosted inside CAC1, located in 81 VU. The CMA allows the maintenance operator to access the System Failure Information report through a single interface. FMA, Flight Management Application, is a software application hosted inside DU2 and DU4, which provides parameters related to the aircraft during flight, such as latitude, longitude, clock, fuel quantity, etc. RMA, Radio Management Application, is a software application hosted inside DU2 and DU4, which provides the parameter related to the flight identification. Landing gear provides air-ground aircraft status for maintenance needs. Aircraft relays provide information necessary to assume the OOOI out, off, on, in function. The recorder A429 interface provides the future possibility to forward data link messages information to the recorder system. The CMU is supplied with 28 VDC from the DC bus 2. The ECU power supply is provided by the CMU. The VHF-3 system is supplied with 28 VDC from the DC bus 2. During flight, pilots are informed of the data link status. Reception of ACARS message on board. Information related to ACARS message reception is provided through two lights located on the glare shield. Information related to data link loss is provided through a flight warning alert and is displayed on EWD, Engine Warning Display. Both ACARS message lights are temporarily inhibited during takeoff phase with the same principle as for caution lights, takeoff inhibit logic. For maintenance purposes, the CMU and VHF3 are connected to the Centralized Maintenance Application, CMA. CMU and VHF3 maintenance data are used by the CMA hosted in CAC1 to provide the ground crew with diagnostic information available on the MPC MCDU pages. It is used to identify the root cause of any failures on the CMU and the VHF3. In addition, an interactive byte self-test, which is available on ground only, is selectable through the MPC menu on MCDU maintenance pages. The primary method to set VHF frequencies is through the MCP's COM VHF pages. MCP control panel and its associated symbology displayed on VCP are explained in the Virtual Control Panel chapter. The secondary way to set VHF is through the MCDUs. Menu push button gives access to the menu page. L3 key gives access to Radio Management System 1, RMS 1, and L4 key to Radio Management System 2, RMS 2, and the associated communication page is displayed. RMS push button gives quick access to the radio management system of your own side. RMS 1 for CM1 or RMS 2 for CM2, and the associated communication page is displayed. On communication page, a frequency may be typed with the keyboard in the scratch pad. The value is displayed in yellow. This frequency is moved to active VHF1 by pressing L1 key, or moved to active VHF2 by pressing R1 key. The new frequency is displayed in yellow for 1 second before changing to blue. On communication page, and if nothing is entered in the scratch pad, L1 key gives access to VHF1 page and R1 key to VHF2 page. When a frequency is typed in the scratch pad, the value is displayed in yellow. L1 key is used to move it to active location. The new frequency tuned is displayed in yellow for 1 second before changing to blue. R1 key is used to move it to standby location. The new frequency selected is displayed directly in blue. Another press of R1 key is used to swap standby and active frequencies. If a frequency is typed in the scratch pad, when L1 key is depressed, the frequency moves to the active frequency location in yellow for 1 second and is replaced by a close frequency in amber, meaning that the frequency tuned by the radio is not the same one as the selected frequency, or is replaced by fail in amber if the radio is failed, or by amber dashes if no feedback is received from the radio. If wrong format frequency is typed in the scratch pad, when L1 key is depressed, the current frequency remains tuned and format error amber message is displayed in the scratch pad. If wrong range frequency is typed in the scratch pad, when L1 key is depressed, the current frequency remains tuned and range error amber message is displayed in the scratch pad. R3 key gives access to the preset page. To modify or to add a new frequency, type a valid frequency in the scratch pad. Press one of the 10 keys between L1 and L5 and R1 and R5 inclusive. The frequency in yellow in the scratch pad is moved to the selected location and is displayed directly in blue. Now, to use a preset frequency, press the key corresponding to the selected frequency. This frequency is moved directly to the scratch pad of the VHF page. Then press L1 or R1 to move it to active or standby frequency. On VHF page, R5 key gives access to the squelch (SQL) mode. On or off mode may be selected. Active mode, here off, is displayed in green in large type. Standby mode, here on, is displayed in blue in small type. Squelch parameters are replaced by amber dashes if corresponding VHF is reported failed. To activate the emergency EMER frequency, press R6 key. 121.500 is displayed directly in blue in active frequency. ACARS, Aircraft Communication Addressing and Reporting System, also called Data Link, is a system that provides for the transmission of digital data to and from aircraft. The application menu of the ACARS Data Link, DL, is accessible by pressing DL key on the MCDU. It is divided into 3 parts. AOC, Airline Operation Communication. AOC menu and all menus selected through this menu are generated by the CMU AOC software. AOC services provided by the AOC application are in accordance with specific customer requirement. It can include the capability to send and receive pre-formatted text, free text messages, retrieve various weather reports, recall flight plans, and automatically transmit position, time reports, etc. ATS, Air Traffic Services. ATS, provided by the ATS application, include the ability to retrieve Air Traffic Information Service, ATIS, Air Traffic Control, ATC, flow and clearance reports, departure. ATS services. ATIS reports contain traffic information associated with the departure and arrival airports. Clearance reports contain information associated with pre-departure clearances. Technical applications. The technical application provides a collection of interfaces which are used to view system status and update systems parameters and certain test capabilities. This application can be used to display various configuration part numbers, the connection status of peripherals, the data link status of each available data radio, and the current state of various discrete inputs. This application can also be used to access and update data contained in the external compensation unit and set a clock used by the other data link applications. The HF system is used for all long-distance radio communication between aircraft in flight or on ground and ground stations. The aircraft can be optionally equipped with one or two HF systems designed to operate in the 2 to 29.9999 MHz range, providing a selection capability of 280,000 channels spaced at 100 Hz increments. The dual HF system includes two transceivers with integrated power amplifier located in the aft cargo ceiling, a radio management application, RMA, hosted in DU2 and 4 to manage HF parameters, two antenna couplers located also in the aft cargo ceiling, and one shared antenna located in the vertical stabilizer leading edge, which enables the reception of two frequencies, but transmission of one frequency at the same time. HF1 system is powered by DC bus 1 and HF2 system by DC essential bus. Note, if single HF option is selected, HF2 will be installed. The HF system is also connected to the remote control audio unit. Both HF are connected to both RMA, which are also monitored by both FWA. An optional cell CAL system can be installed associated with HF as with VHF. A specific and unique cell CAL code composed of 4 letters is allocated to the aircraft during its assembly. When a ground station wishes to call a specific aircraft, it uses the aircraft assigned code through an encoder. A visual and double tone signal are triggered in the cockpit to indicate a communication request. The radio volume, previously set to minimum, is adjusted by the pilot to start the communication. The primary method to set HF frequencies is through the MCP's COM HF pages. MCP control panel and its associated symbology displayed on VCP are explained in the Virtual Control Panel chapter. The secondary way to set HF is through the MCDUs. Menu push button gives access to the menu page. L3 key gives access to Radio Management System 1, RMS1. L4 key to Radio Management System 2, RMS2, and the associated communication page is displayed. RMS push button gives quick access to the radio management system of your own side, RMS1 for CM1 or RMS2 for CM2, and the associated communication page is displayed. On the communication page, a frequency may be typed with the keyboard in the scratch pad. The value is displayed in yellow. This frequency is moved to active HF1 by pressing L2, or moved to active HF2 by pressing R2 key. The new frequency is displayed in yellow for 1 second before changing to blue. On communication page, and if nothing is entered in the scratch pad, L2 key gives access to HF1 page, and R2 key to HF2 page. When a frequency is typed in the scratch pad, the value is displayed in yellow. L1 key is used to move it to active location. The new frequency tuned is displayed in yellow for 1 second before changing to blue. R1 key is used to move it to standby location. The new frequency selected is displayed directly in blue. Another press of R1 key is used to swap standby and active frequencies. If a frequency is typed in the scratch pad, when L1 key is depressed, the frequency moves to the active frequency location in yellow for 1 second and is replaced by a close frequency in amber, meaning that the frequency tuned by the radio is not the same one as the selected frequency, or is replaced by fail in amber if the radio is failed, or by amber dashes if no feedback is received from the radio. If wrong format frequency is typed in the scratch pad, when L1 key is depressed, the current frequency remains tuned and format error amber message is displayed in the scratch pad. If wrong range frequency is typed in the scratch pad, when L1 key is depressed, the current frequency remains tuned and range error amber message is displayed in the scratch pad. If wrong format frequency is typed in the scratch pad, when R1 key is depressed, the current frequency remains tuned and format error amber message is displayed in the scratch pad. If wrong range frequency is typed in the scratch pad, when R1 key is depressed, the current frequency remains tuned and range error amber message is displayed in the scratch pad. R3 key gives access to the preset page. To modify or to add a new frequency, type a valid frequency in the scratch pad. Press one of the 10 keys between L1 and L5 and R1 and R5 inclusive. The frequency in yellow in the scratch pad is moved to the selected location and is displayed directly in blue. Now, to use a preset frequency, press the key corresponding to the selected frequency. This frequency is moved directly to the scratch pad of the HF page. Then press L1 or R1 to move it to active or standby frequency. On HF page, R5 key gives access to the squelch SQL mode. Off, 1, 2 or 3 squelch mode may be selected. Active mode, here 3, is displayed in green in large type. Standby mode, here off, 1 and 2 are displayed in blue in small type. Squelch parameters are replaced by amber dashes if corresponding HF is reported failed. On HF page, R6 key gives access to the power mode. Low, medium or high, low, med or high power mode may be selected. Active mode, here high, is displayed in green in large type. Standby mode, here low and medium, are displayed in blue in small type. Power parameters are replaced by amber dashes if corresponding HF is reported failed. On HF page, L2 key gives access to the HF mode. On or standby, on or STBY mode may be selected. Active status, here on, is displayed in green in large type. Standby status, here STBY, is displayed in blue in small type. Mode parameters are replaced by amber dashes if corresponding HF is reported failed. On HF page, L3 key gives access to the modulation mode. USB or AM mode may be selected. Active status, here USB, is displayed in green in large type. Standby status, here AM, is displayed in blue in small type. Modulation parameters are replaced by amber dashes if corresponding HF is reported failed. The passenger address system enables the crew members and the cabin attendant to transmit announcements to the passengers. Connections are made through the passenger address amplifier, PA, which is installed in the avionic rack. The passenger address is connected to the Digital Remote Control Audio Unit, RCAU. This connection enables the captain and the first officer to transmit announcements to passengers without using any special telephone handset. The cockpit announcement has priority over cabin attendant announcement and tape reproducer. The MFC's connection enables the passenger address sound attenuator to be inhibited as soon as one engine is started. This results in the announcement volume increasing by 6 dB. A telephone handset located at the cabin attendant's forward and aft stations. The forward attendant handset is optional. 12 loudspeakers distributed throughout the passenger compartment. One loudspeaker is located in the lavatory and one is located in the galley. Note that the MFC's connection also enables the muting of the galley loudspeaker when a cabin attendant handset is used to avoid acoustic effect. The passenger address is also connected to a music tape reproducer, which can be used to broadcast automatically any passenger announcements before the flight, as well as music in the cabin. It is muted each time a message is broadcasted from flight crew members or cabin attendant. The DC Essential Bus. The flight compartment attendant push button, located on the call's control panel. The attendant call lighted push button, located on each passenger service unit, PSU, which sound a chime at each activation. And to the cockpit voice recorder system. All aircraft must have an automatic beacon on board, and depending on the flight plan, 1 or 2 extra portable beacons that will be carried by the flight attendant in case of evacuation. An automatic emergency locator transmitter, ELT, must be attached to the aircraft in such a manner that, following a crash, the ELT transmitting signal is maximized. The ELT system comprises a transmitter in the pressurized ceiling close to the toilet door. An antenna in the fairing ahead of the stabilizer fin. A remote control unit in the flight compartment. A lithium battery with a lifespan of 5 years, enabling about 60 hours of transmission. The ELT is able to transmit a distress signal on 121.500 MHz and 243.000 MHz frequencies, and a geographical position signal on 406.000 MHz frequency. The ELT control panel is located on the overhead panel. A master switch is used to select the operation mode of the ELT. In auto, the transmission is made automatically when the deceleration exceeds 5G. The manual mode, man position, allows commanded operation. When the transmission is made, the X-MIT alert light illuminates amber. The auto test reset push button is used to reset the ELT in case of undue alert. It is also used to test the ELT. If the test is successful, the X-MIT alert light illuminates for 2 seconds. In case of unsuccessful test, the light flashes for 15 seconds. Be aware that the test must not be performed in manual mode. On ground, the mechanic call horn is activated after 30 seconds when the ELT is triggered. In case of communication system failure, refer to the Master Minimum Equipment List (MMEL) of ATA 23.
Your answer is correct. 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 Your answer is correct.
TCAS is Traffic Alert and Collision Avoidance System and is a part of the T2 CAS. TCAS is intended as a supplementary aid to the pilot in detecting the presence of nearby aircraft and determining their potential as an airspace threat. The system interrogates the nearby aircraft's transponder and uses its replies to compute a predicted flight path for the aircraft. With this information, the TCAS can determine a potential collision risk. The directional antenna is used to determine the direction of the other aircraft. Mode C, altitude data, from the other aircraft's transponder reply gives altitude information. These data advise the flight crew of recommended vertical maneuvers to avoid the other aircraft. When both aircraft are TCAS equipped, the TCAS transmit receiver coordinated the advised maneuvers of each aircraft in the vertical plane only. If an intruder is equipped with a transponder mode A, only bearing information will be given to the aircraft. If an intruder is not equipped with a transponder, it is invisible to TCAS. TCAS is composed of one transmitter receiver embedded in T2 CAS located in the avionic rack. It transmits and receives UHF signals for the detection of any intruders, computes the intruder trajectory, and provides signal to generate the appropriate intruder symbol and the associated oral warning. One directional top antenna and one omnidirectional bottom antenna, used for transmitting and receiving. They detect the bearing of the intruder, which is in the detection volume of TCAS. In addition, TCAS uses the 4 ATC antennas for communication. TCAS is interfaced with Attitude and Heading Reference System, which send heading information to the TCAS transceiver to locate the intruder. TAWS, which is integrated in T2 CAS computer. TAWS warnings have priority over TCAS oral warnings. Radio altimeter, RA, which provides radio altitude information. Below 2,500 feet, TCAS uses RA information as a reference to determine sensitivity levels. No RA information is used below 700 feet. ADC, which provide the barometric altitude. Above 2,500 feet, the TCAS uses barometric altitude information as a reference. ATC 1 and 2, which allow data exchange between own aircraft and TCAS-equipped intruders. The TCAS is also interfaced with flight environment data, landing gear, flaps, through the MFC, remote control audio unit for audio outputs, display unit for TCAS displays and controls on PFD and MFD through CACs, MPC through CACs for recording function. TCAS function and displays are configured through the Virtual Control Panel (VCP) via the Multifunction Control Panel (MCP) and the MCDU. TCAS function modes are selected via the TCAS tab in the Serve VCP pages. When Standby is selected, TCAS system is in standby. No traffic information is provided. When TA Only is selected, only traffic advisories are transmitted to the crew. No resolutions are issued. When Auto is selected, TCAS generates both advisories and resolutions. This is the normal TCAS operating mode. TCAS display modes are selected via the Overlay tab on the NAV VCP pages. When None is selected, only TA and RA information is displayed. When Below is selected, the traffic detection range starts from -9,900 feet up to +2,700 feet. When Normal is selected, the selected range is ±2,700 feet. When Above is selected, the traffic detection range starts from -2,700 feet up to +9,900 feet. TCAS is also controlled through the MCDU by selecting the TCAS tab in the Communication page. The TCAS operating mode can be changed by pressing the L1 MCDU key. The display mode can be changed by pressing the L3 key. The status of the TCAS system is also shown in the Communication page. The TCAS information is displayed on the PFD for the TCAS mode and the resolution advisory corrections, on the MFD in ND configuration for the traffic background and the TCAS mode. Current TCAS mode can be read either on the PFD and on the MFD in ND configuration. Various messages reflect the mode status of the TCAS system. MFD displays the traffic information on the ND page. Traffic is displayed differently according to their danger. A solid red square represents an immediate threat to the aircraft. A resolution advisory, RA, is triggered when intruder is within 15 to 35 seconds around aircraft. A solid amber circle represents a moderate threat. A traffic advisory, TA, is triggered when intruder is within 20 to 48 seconds around aircraft. A solid white diamond represents proximate traffic, which is within 6 nautical miles and within plus or minus 1,200 feet vertically, but whose path is not predicted to penetrate the collision area. An empty white diamond represents the other traffic, which includes any transponder replying aircraft within the horizontal and vertical range of the display and not classified as proximate traffic or as intruder. In addition to the symbol, a data tag is displayed. It consists of the relative altitude difference indication in hundreds of feet and plus or minus sign for higher or lower altitude. If the target aircraft is climbing or descending at 500 feet per minute or more, a vertical arrow is pointing up or down. When bearing is not available, a message indicates only RA or TA intruders with their range, altitude difference, and vertical path. In case of resolution advisory, RA, preventive or corrective indications are displayed on the vertical speed scale. The vertical speed indicator is the primary instrument used by the pilot to determine what vertical adjustment is necessary. The pitch attitude must be adjusted in order to set the vertical speed pointer into the green segment. The red segment is the vertical speed region to be avoided. The green segment is the safe vertical speed region. The vertical speed pointer and readout color is set according to the situation. Red if they are within the red segment, green in the other situations. Let's consider an ATR 600 flying in cruise and another aircraft equipped with a Mode A transponder. The TCAS detection capability is limited to intruders flying within a maximum range of 100 nautical miles and within a maximum vertical sector of 9,900 feet above and below the aircraft. Whilst TCAS system interrogates the surrounding airspace and as the intruder is out of detection limit, nothing is displayed on the ND. The intruder now reaches the proximity advisory PA limit. The TCAS interrogates the intruder transponder. The intruder transponder answers with a Mode A code. The TCAS computes the intruder distance and bearing and displays its symbol on the ND without any data tag. The TCAS continues the interrogations and updates the intruder range and bearing. It is the tracking phase. When the intruder reaches the traffic advisory TA limit, the symbol changes in shape and color, and an oral warning announces this TA.
Traffic.
As the intruder is not transmitting any altitude data, it is considered as being at the same altitude. TCAS does not provide any resolution advisory RA when the intruder reaches the RA limit with a Mode A equipped aircraft. Let's consider now an intruder equipped with a Mode C or S transponder. As soon as the traffic reaches the PA limit, the TCAS interrogates the intruder transponder, which answers with a Mode C or a Mode S code. The TCAS computes the intruder bearing, distance, and relative altitude difference and displays them on the ND. All these data are continuously computed during the tracking. When the intruder reaches the traffic advisory TA limit, the symbol, shape and color change and an oral warning announces this TA.
Traffic.
As soon as the intruder reaches the RA limit, the symbol changes in shape and color. The TCAS computes the vertical separation for climbing or descending. It selects the direction providing the greatest separation and chooses the least disruptive vertical rate maneuver that achieves safe separation. The chosen maneuver is shown on the vertical speed scale of the PFD and announced by oral alert. During the maneuver, the TCAS continues the tracking and issues enhanced TCAS maneuvers when the initial TCAS RA does not provide sufficient vertical separation. It is also announced by oral alerts with a constant increased urgency in the tone.
Climb, climb.
We consider now that the intruder is equipped with a Mode S transponder and a TCAS transceiver. As soon as the traffic reaches the PA limit, the first TCAS to detect the other one initiates a data exchange with the intruder. The TCAS computes the intruder bearing, distance, and relative altitude difference and displays them on the ND. All these data are continuously computed during the tracking. When the intruder reaches the traffic advisory TA limit, the symbol changes in shape and color, and an oral warning announces this TA.
Traffic, traffic.
As soon as the intruder reaches the RA limit, the symbol, shape and color change. The TCAS computes the vertical separation for climbing or descending. It selects the direction providing the greatest separation using data received from the intruder TCAS system to coordinate the maneuver. The chosen maneuver is shown on the vertical speed scale of the PFD and announced by oral alert. During the maneuver, the TCAS continues the tracking and issues enhanced TCAS maneuvers when the initial TCAS RA does not provide sufficient vertical separation. It is also announced by oral alerts with a constant increased urgency in the
Climb, climb.
When the intruder has passed and there is no longer any RA, the symbol changes shape and color and an oral alert is triggered which confirms the situation. Also,
Clear of
red
conflict.
and green segments disappear on the PFD. If during a RA the aircraft track or altitude information is lost, the RA will end without a clear of conflict annunciation. In case of TA or RA alert activation, the MFD ND is set to ROSE with a 10 nautical mile range.
Traffic, traffic.
Under specific conditions or flight phases, own aircraft's climb performances may be limited, such that it cannot execute a climb maneuver at 1500 feet per minute. Also, some kinds of RA can be inhibited in certain circumstances. For example, requesting a descent with the aircraft already at low altitude. In case of TCAS failure, refer to the Master Minimum Equipment List, MMEL, 34, page 2D.
Your answer is correct. 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 Your answer is correct.